Thanks, Josh. I'm not quite sure what the nature of this group is, but I take it from your title of Science and Reason that you're interested in looking at these questions from a more philosophical perspective, and reflecting on what you can find out and what you can't find out from science and so on. And with an emphasis, I take it, I'm looking for explanations that don't appeal to something mystical or whatever. I mean, is that a fair guess?
I guess.
It's just that if I was going to think in terms of science and reason and those two things put together, I'd go back a century or so and think in terms of some of the debates that there have been more about the character of life and evolution than the origin of life as such. But from my point of view, those questions are very much tied together, because when you look at the origin of life, the first question you have is, what is it that you're trying to explain? Well, on the face of it, that's simple. We're sitting in the room, we're alive, and where do we come from? Or how did the whole process start? But what aspects of that process are important and needing an explanation in terms of science? If you take a radically materialistic point of view and you accept that what physics describes is all there is, then you end up being rather limited. And in fact, there isn't very much to explain except to seek a whole series of events, and you just get into the realm of what is a plausible argument, what is not a plausible argument. Let's say in terms of molecular processes for something happening, and then you try and string together a whole series of events which may have ended with us being here. Okay, so that's the point of view that you do get with a lot of people who write about evolution, and then there are others who try and say, well, are there some characteristics of organisms which it's no use trying to explain in terms of physics? Is there a kind of organisation, either just formal or inherent within the basic laws of nature, that mean that we're going to probably, in our universe, end up with something like what we are, probably elsewhere in the universe not anywhere near exactly the same as us, but nevertheless having similar characteristics. And the question is, what are those characteristics? Okay, so if we then go back to the very beginning, we want to say, what is it that would distinguish a molecular system which we'd want to say was living from one that wasn't living? And then how would we explain the origin of that thing? So there's a lot of chemistry in the discussion of the origins of life. There's a lot of geology, really, because you have to ask, what are the circumstances under which the kind of reactions that of the sort that must have taken place, did take place, or could take place. So some people look for the origin of life in the kind of chemistry that takes place deep in the ocean around smokers, as they're called, those submarine volcanoes that spew up stuff. Other people look for it in terms of cyclical processes taking place in generally speaking, smaller locales, but they try and explain the kind of ordering that took place in the chemistry in terms of diurnal cycles, for example, the sun warming something up and then cooling down at night, warming up and cooling down at night, and this providing some sort of set of circumstances under which you could get, if you like, a cyclical process that had some sort of output that got frozen into some ordered form. People have all sorts of explanations like that. Then there are others like my colleague Stuart Kaufman, who looks for ordering principles, if you like, in chemistry, in the organisation of systems, in particular in the organisation of chemical systems. So all of these are open questions, and the kind of answer that you give to what is the origin of life depends very much on how you pose the question. So what I tend to do to take as my starting point is a little book which I recommend to everybody all the time, which was written by the physicist Schrödinger around about the time of the end of the Second World War, around 44, 45. He wrote this little book called What is Life, in which he tried to ask what are the characteristics of living organisms when you look at the very lowest level, when you look at molecular events, and what is it that distinguishes what happens in a living cell from what happens in other chemical systems, if anything. And of course he took it as, well, I'm only going to talk about people who take it as given that the same laws of physics apply to living systems as apply to non-living systems. And so he says, what is the distinguishing characteristics? And in order to explain even the level of organisation which was known then, he concluded that living organisms, in order to pass on the characteristics as they did from one generation to another, must contain something which had the form of information. And by information, he said some sort of detailed molecular structure. He took it to be a quantum structure in a crystal, actually, which could be replicated and could be maintained and copied in a stable form from generation to generation. Otherwise, how could you explain the fact that all the emperors on the portraits of all the emperors on the wall in Vienna at the art gallery where he'd been all had the same shaped lip? He said, how could you, going through all the disordering molecular processes that happen as a result of just temperature, how could you, through all of those processes, maintain the information about this one characteristic over several hundred years? He said, you must have information stored somewhere. And he came up with the idea of a quasi-periodic crystalline structure, which is a good description of the linear structure of DNA. So Schrödinger is often taken as having been the person who provided the first ideas for molecular biology. Crick certainly said it was what had inspired him to take up the quest to try and understand the processes of life in molecular terms. And those of you who have read anything of Crick will know that he became something of a maniac for trying to explain everything in terms of the molecular terms that we understand from biochemistry. So he wrote books about he wrote one book called Life Itself. He wrote another one, well, let's put it this way, at the end of his life he was trying to tell us how it is that everything that happens in our brains can be explained, or at least described in molecular terms. Okay, so Schrödinger gave us a first look at what life might be in molecular terms, and the second thing that he said, other than giving this idea of information, was that he described how life did not basically violate the laws of thermodynamics, which is another thing that I take to be a given. And in fact, a lot of people have since that time developed theories of thermodynamics for an explanation of what it is that distinguishes living systems and generally ordered self-organized systems from others, and I think particularly of Ilya Prigogine and his theory of dissipative structures. So if we're looking for an origin of life, what I'm looking for is the beginning of some sort of system in which a chemical, in which chemical processes confined in a particular space can be said to be processing information which they hold and which is able to be copied in the process of reproduction. And when you're processing information, you can be said to be doing something symbolic, or the system can be said to be doing something symbolic. Because as soon as you model anything in terms of information given as a program, and the execution of the execution of that program in terms of an algorithm, that algorithm and its execution can represent a large number of different things. And you know about the argument the other way around. You can take a calculation that you want to do and you can code it up in a huge different number of ways and get the same result symbolically. That is the calculation that you want to get done with different hardware, with different software systems, and so on. And when you look at a living system, I take it as being something which is operating in an algorithmic fashion about itself. There is some way in which the information is being used in a self-referential fashion, and it is a particular encoding, in terms of DNA and RNA and protein and so on, particular encoding of processes which maintain their integrity over time and which are able to spawn off copies and pseudo-copies of themselves all over the place. So that is the thing that I try and look for an explanation for in terms of the origin of life. What sort of chemical processes can get going in which information, which is self-referential in some sense, gets executed? And to me, that's a much broader question than just asking about the chemistry itself. You can know endless stuff about DNA and endless stuff about proteins, but unless you understand the symbolic relationship between the two, that's why I'm interested in the origin of the genetic code. It seems to me that you're not studying anything to do with biology or the origin of life at all. And then if you want to ask the deeper philosophical question, in the same way as you can ask, what is the origin of the universe? You know, where did the Big Bang come from? Whatever. You can ask the same thing about the processing of information, which is somehow self-referential in the universe as well. Because sure as hell, it seems to me, there's self-referential information processing also taking place at a different sort of level within my head right now, and through a few little sound waves I'm able to communicate it to you, and you're able to take meaning from that, and it's completely symbolic. It's got nothing to do with the sound waves, except that happens to be the material means of transmission. There is information and meaning being communicated, and so to me that's what the origin of life is about. Why is it and how is it in the universe that anything like that gets going? I'll leave it at that for an introduction.